So we will start by talking of monoliths. Then we'll move forward to understanding the concept of scale. What does scale imply? How is it measured? What are the different dimensions of scale from a very famous concept? Then we'll get into microservices, have some definitions, define them. Look at what is good about them and what are some of the drawbacks of microservices. Let's talk about microservices. We will get into what's good about them, what's bad about them, when are they useful, when are they not. And then we'll take a bit deeper dive into the pattern language for microservice with an example. Let's get started. So we will start by talking of monoliths. Then we'll move forward to understanding the concept of scale. What does scale imply? How is it measured? What are the different dimensions of scale from a very famous concept? Then we'll get into microservices, have some definitions, define them. Look at what is good about them and what are some of the drawbacks of microservices. Then we'll take a look at microservice architecture pattern language, which we'll talk about, where we'll get into different kinds of microservices pattern as to what are the different views and viewpoints that, when you're building an application with microservice, you want to leverage them. And then probably we'll move to a summary. Most of the conversation in this is, this is my sketchboard, which I've drawn to use this. Let's get started. So the first thing we want to talk about is monoliths. Now, monoliths been around for quite some time, right? They are simple to develop. It's very easy to make changes into monoliths. They are straightforward to tests. They are easy to get started. They are easy to deploy, and in a lot of sense, they are actually very easy to scale. You just put monolith behind a load balancer and you can run multiple instances of it. Let's take a look at a simple monolith example and then we'll talk about. So let's imagine, this is a large monolith called FTGO application. It's accessed by REST APIs, and then there's a web UI. So this Android app or iOS apps interacting via RESTful APIs, and then you have web UI directly talking to them. Now this application has one large module, and inside it there's different sort of functions or capabilities built into it. There's restaurant management, order management, payments, etc. And then there's an adapter for database connection. And then there are different payment adapters, right? You have different cloud services from an integration standpoint. So if you think about it, it's one large single code base. It's a very important concept to visualize. It's kind of a mono repo, and it has its interaction managed by those agents. So this is how the application goes, right? And let's probably talk about some of the drawbacks of it. Let's open the diagram again. So for instance, if somebody is just changing the delivery management, the entire application has to be redeployed. If there's a change on the Twilio adapter or if some kind of a Stripe changes some of their methods for payment, the entire application has to be redeployed. So if you are a developer and if you are trying to build the application and you're working on payments module, irrespective of the fact if no changes have been made to the entire system, you have to build the whole application, which could take long time, right? So that's some of the challenges from a microservice, from a monolith perspective. Now, when we talk of monolith, right, there's few things that are good and bad. I just talked about the good things. I think they're simple to develop, they're straightforward to test and all that. Now, the bad thing is, as I was talking, complexity intimidates developers, and as things get big, it gets very complex. Development is slow, and that's what I was just giving an example. When you want to build and the whole application, it will typically require you to have the whole jar file built for the entire code base, not just your own module, right? There could be challenges when you want to scale. Yes, it is relatively easy when you want to just run multiple instances of it, but if you have different configurations for different modules, for example, one module requires some sort of an in-memory database, other requires high performance compute, there could be another module where IO is high and things like that. It becomes very different to separate and segregate cut concerns for these different modules. And then you really have a challenge in delivering it. If you think about it, from a CI/CD perspective, it's a very large application. So testing it every time a small change is made is a big task, and the reliability of the whole application comes to question when there's changes involved in it. And finally, you also have a lot of lock-in into technology stacks. For example, and PHP is a great example of it. When people started building applications in PHP, they end up with one large code base. Yes, there are attempts to build frameworks around PHP, bring microservices in the conversation, but intrinsically there is a lot of complexity involved, right? So I'm not trying to paint a picture that monoliths are bad or anything. I'm just trying to do a comparison of the goods and the bads around it. Now, when we talk of microservices, one of the key conversations that people throw around is, hey, let's talk about scale. So let's try and understand scale from a different perspective, right? There is a very popular concept which is called a scale cube. This was introduced, I think, by some famous architects around 2005. I will leave the reference of the book in the description. What it basically talks is that think of a cube, right? X-axis, Y-axis, and Z-axis. So the scale cube typically defines three separate ways to scale an application. X-axis scaling will talk about load balancing requests across multiple instances, so kind of the monolith way. Z-axis will talk about request about the one certain attribute of an object. So it could be by user, it could be by time, it could be by year, it could be a certain category, it could be a product. So that's Z-axis. Y-axis talks about functional decomposition, which is microservices. So this is the scale cube for you, which for a reference. So X-axis, Y-axis, and Z-axis, right? Let's take a look at each of them. What does X-axis scalability mean? So this is what X-axis scale would imply, right? This is a standard monolith. So you have a load balancer, which is routing request using some load balancing algorithm like round robin, last in first out, or first in first out, sticky sessions, etc., etc. And you have n identical instances, and each instance is having the same code base running the same. It's essentially the same application instance running. There could be session replication between them and all that, but we are not getting into those complexities, right? Then there is a Z-axis scaling. Note, I'm not talking Y-axis, I'm talking of Z-axis. Now, Z-axis scaling is about data-based scaling, right? You still have the same monolith, you still have multiple instances, but what you have achieved is you have tried to separate the access, separate the calls basis a data point. Now this could be as in the case of the image, right, that we have on the screen, applications, users. So it could be users A to H, users I to P. It could be across a very different partition. For example, you have different products, categories, and you want partition. You have partitioned your data by product category. So you might go by product category scenario. You could go by time also. That could be another way to look at it. So this is about data-based partitioning and scaling using data. This is a very common way to scale, I would say, if you are working with monoliths, and it's actually a great way to scale as well. Now the third axis, which is Y-axis, is what is microservice, right? So the Y-axis splits the application into set of services. And what happens is that each service is responsible for a particular function. And each of that service can independently be scaled using the X-axis scaling and maybe even the Z-axis scaling, right? So that's what microservices is all about. So you scale the application functionally by decomposing it into different services. So that's what is a scale cube, right? Please remember, the scale cube gives a great way to define scalability. When we talk of scalability, people often just think of one single axis kind of a scalability, but scale cubes gives us a way to define the define the scalability of it. So now let's take a look at some of the definitions, right? So if we have reached at this stage, what can we talk about microservices? We can, let's zoom this further, we can very safely say that microservices are a high level architecture. It's a architecture style where we do functional decomposition of an application into a set of services. Now there is no talk of this size. What matters is that each unit, each service has a very well defined, focused, and a cohesive set of responsibilities. There's no, a lot of external dependencies. It has an independent identity. Let's take with that. We can also think of it as a form of a modularity, in a way of breaking down from a modularity perspective. So when we have a large application, what are we trying to do is we are trying to modularize the application by using a certain style, which is functional decomposition. Now, the third point would be that microservice architecture uses services as a unit of modularity, which is combining the point 1 and 2. And then a service has an API, which is an impermeable boundary that's difficult to violate. Now in API, it doesn't say REST or SOAP or gRPC and stuff like that. It just says an API, which implies that services should be talked to or fro by APIs. And that's the boundary. Inside that boundary, the service is a very well-defined cohesive unit, independent cohesive unit, right? Let's try to move further and look at, what could be a version of the FTGO application as a microservice, right? So now we see that there's some different constructs that we have, right? We have an API gateway, which was not present before. I think an API gateway is a conversation we'll have in future. You have restaurant web UI. Notice every service has a REST API, right? And API gateway is also talking to those REST APIs. So in a nutshell, this is a completely API based conversation. Now services can correspond to different business capabilities. It can follow different domains and stuff like that, which is what the decomposition of a microservice is all about. So there's an order service, there's a restaurant service, kitchen service, notification service, and blah blah blah. And each of the different services, note that have their own units that they need to interact with. For example, accounting service is talking to Stripe adapter. A notification is talking to Twilio and SES adapter. So if there was a change on Stripe API, there's just one single service that needs to probably go down and be updated. So there's tons of. Let's talk about the advantages now that we have understood about the APIs, right? So I think it's very, very straightforward, but from a foundational perspective, what is it enabling? What are the benefits? Services are independent. They are independently deployable and they are independently scalable, right? People or teams can be independently work on them. It's also very much possible to have a service A in a PHP technology, service B in Python, and service C in Java. Though it's not recommended that you bring in so many different tech stacks, but it's very much possible. And it enables the solution to the problem that each of the different service has different kind of computing needs. So if you have a service where you are dealing with high amount of concurrency, you might want to do Go routines. You can definitely do that, right? There's a good and a nice fault tolerance which is natively built into the system. There's no single point of failure. And it's kind of also very sane from a CI/CD and testability standpoint, right? So these are some of the benefits of microservices. Let's try to look at some of the drawbacks why microservices is not a good idea. It's not a silver bullet. Again, I'm not suggesting that microservices are better from monoliths, but what we are talking about is how do each contrast each other. So one of the first things that I always believe is finding and decomposing services is very, very challenging, right? There isn't a concrete, well-defined architecture or a solution which you can say that, hey, tick 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 tick, checkbox is done, this is the service you need to go. It's kind of difficult to arrive at a good service design or a microservice design. Right? I think that's true for even a service design. Distributed systems inherently are complicated because it's very difficult to test them. Now, while we have eliminated the size problem and some of the challenges, what we have created is a new kind of a problem, right? Because of the nature of services, that there's so much of interaction happening with external world in order to provide an end-to-end functionality. What happens is if you are testing a restaurant service update or a kitchen service update and other services are not changing, is you need an environment where all other services are running at a stable level. So it's kind of difficult to it's kind of difficult to bake that testing in the ecosystem, build that connectivity across different APIs, have multiple environments and stuff like that. Now, another thing which is challenging is if you are deploying services or features, deploying features which span over multiple services, that could be a very challenging task and could require careful coordination. And last is the adoption itself, or actually I will probably add one more than what I've written here. Adoption of microservices itself is large. There's a lot of different challenges from on the perspective of I already talked about decomposition. There's people challenges because the understanding of the design is not very direct. It takes some time for teams to get in a buy-in to do microservices or to think microservices. Sometimes because systems have been built over a period of time, large or typically older systems which predate, let's say 5-7 years before, which were written 5-7 years before, they're still running in kind of a hybrid / monolith-ish environment. So that's another challenge. Second is, if you don't have how do you know if you have a need for a microservice, right? It's very, very difficult to identify the need for a microservice. And that's also a cause for a major dilemma. So if you're a small organization or a startup, I don't think you should even talk about microservices. You should almost always begin with monolith. And then as you grow and you have a more understanding of what you're trying to build, then you should do decomposition. Because functional decomposition or a decomposition is effectively a very hard exercise. Right? Let's move forward to a different topic now. Let's move forward to microservices architecture pattern language, which is a collection of patterns that can help architect an application using microservices. So there's broadly 3 different kind of architecture patterns that we have on the screen. There's an application pattern which fundamentally talks at the application level, which is how do you decompose, how do you talk to your database, how do you query, how do you manage testing, how do you have consistency and stuff. Then there's an application infrastructure pattern which is overlapping with infrastructure and has communication, security, messaging, etc. requirement. And the third is from a microservice deployment or infrastructure perspective as to what are the different kind of patterns that you have. So these are the 3 different think of them as problem areas. These are the lot of different problem areas, and there are different patterns solving each of them, right? So that's microservice pattern architecture, pattern language. And as I just mentioned, the pattern language has 3 different layers. So let's summarize. Let's try and understand what we talked as a whole in the whole conversation. So the monolithic architecture pattern structures the application as a single deployable unit, and there are goods and bads to it. While the microservice pattern decomposes the system into a set of independently deployable services. The monolith is a great choice if you're building simple applications, if you're doing startups, if you don't want a lot of complexity in the ecosystem. But hey, if you have a very large scaled complex application, you might want to do microservices, right? Microservice architecture isn't a silver bullet. There's significant drawbacks, and complexity is one of them. Deployment of microservices is opens up a whole together different can of worms. The microservice architecture pattern language gives you a collection of different patterns that can help you design microservices from an end-to-end, from an infrastructure, communication, and an application perspective. And you probably, now the last 2 points are very, very important to understand is microservices alone aren't the key, right? You probably need a great DevOps also that can complement the conversation from a development and application standpoint and build the whole automation and CI/CD around it. And lastly, don't forget the human side of microservices. You need to consider employee emotions in order to successfully transition to microservice architecture. There are systems that are still running in mainframes. There are organizations still trying to do digitization and transformation of the technology. There's a lot of industries which rely on legacy tech, and moving from monolith to a microservice or even a service design isn't a one-day conversation. It requires upskilling your people, it requires understanding their emotions and whatnot. So that's what I wanted to talk about microservices. Thank you for listening to my conversation. Bye bye. Please do subscribe to my channel if you have liked it.